Click the bell icon to get latest videos from Ekeeda.
Hello friends, we have recently seen that DFA and NFA are equivalent in power. That means every DFA is by default an NFA and every NFA could be transformed into a DFA. Now we shall see certain problems in which we will construct an NFA and later we will convert that NFA to a DFA. Let us start with our first problem. In this problem, we are going to construct an NFA which accepts strings over binary alphabet 0 and 1 which starts with 0. Later, we shall convert this NFA to a DFA. First, let us construct the NFA. Let us say Q0 is our initial state for the given NFA. This NFA should accept the set of all strings which starts with 0. On the symbol 0, we will create a new state. Once a 0 is encountered, we know that now all the strings are valid under the given state. Hence, we can mark Q1 as the final state. Now we are done with the creation of the NFA. We can transform the NFA into a transition table. Q0 is our initial state, so we mark Q0. Q1 is our final state, we mark Q1. Now we'll fill the transition. As you can see, Q0 has a transition to Q1 on the symbol 0. So here we will fill Q1. There is no transition from Q0 on symbol 1, so we will fill a dead state 5. Similarly, on Q1 with a 0 input, it is having a transition to Q1 as well as with 1 output, as well as with 1 input, it has a transition to Q1. We have transformed the transition diagram to the transition state table. Now, using the transition table, we can create the transition table for the given DFA. As I discussed earlier, we will start with subsets of given states. We will start with the initial state Q0 on a symbol 0 and on the symbol 1. On symbol 0, we see that Q0 has only one transition, that is Q1. So here we form a new state Q1. On 1, there are no transition, so we will create a new state, that is null. Similarly, now we got a new state Q1, we will write the transitions of Q1. From Q1 on 0, we have a transition to Q1, and 1 also we have a transition to Q1. Using this transition table, now we can draw the DFA for the given NFA. So we start with Q0. This is our initial state for the given DFA. From Q0 on 1, we will go to a new state called Q1. On Q1, we will have transition to Q1 on both 0 and 1. Now we have to identify the final state. We know that in the DFA, the final state is Q1. In this, the only set which contains Q1 is the second one. So this becomes the final set. This is the final state. What we have drawn is an equivalent DFA for the given NFA. But we are left with one more transition. What is it? 0 from Q0. In DFA, every transition is mandatory, whereas in NFA, every transition is not mandatory, and hence the dead state is not shown in an NFA, but we have to show it in a DFA. So on 1, we will have one more state. You can mark it either as a dead state or a new state. This will have no transition. Now, as we are drawing a dead state, we need to enter one more row. Now, this dead state will be in dead state on both 0 as well as 1. With this, we are done with the DFA creation for the given NFA. Let us see the mathematical definition. Let us name this machine as M1 and let us name this machine as M1 cap. We say that M is containing Q, sigma, delta, Q naught and F, where Q is having Q0 and Q1, sigma is 0 and 1, delta is given using this transition table 1. This is transition table 1. Q naught is again the initial state. Here we have Q naught only. And F is the final state which contains only Q1. Let us see the definition of our DFA. Let us see our machine M cap. Let us say M cap is containing Q cap, sigma, delta cap, Q naught and F cap. Let us see these components. We will see that Q cap has the component Q0, Q1 and 5. Sigma is again 0 and 1. Delta is transition table 2. Q naught is the initial state which is here Q0 and F cap is having just Q1. With this, we are done with our first example of converting NFA to a DFA. Let us see one more example. In this example, we are going to construct an NFA which is accepting a language over the binary alphabet 0 and 1 which contains the alphabet 0. Let us take Q0 as the initial state. On encountering a 0, we will go to the final state Q1. It doesn't matter whether now 0 or 1 is encountered. We have already seen 0, hence it is a final state. Now, until we don't see a 0, we will have to wait at the first state and wait for a 0 to encounter. This becomes the state transition diagram for a DFA which accepts a set of all strings which contain 0. Let us draw the transition table. Q0 is our initial state, Q1 is our final state, 0 and 1 are the alphabets. Q0 on 0 has a transition to Q1, Q0 on 1 has a transition to Q0. Q1 has transition to Q1 on both 0 and 1. Let us try to draw the transition table for the given DFA. Now Q0 is the initial state, so we mark Q0 with the initial symbol. Q0 has a transition on Q1 on symbol 0 and has a transition to Q0 itself on 1. Similarly, Q1 has a transition to Q1 on both symbols 0 and 1. As there are no dead states required, we are not including any dead state. Let us try to draw the DFA for the given table. From the transition table, we know that Q0 is the initial state. So we start with Q0 and try to draw the transition. From Q0, there is a transition to Q1 on the symbol 0. So we draw that using this Now, similarly, Q0 has a transition to Q0 itself on encountering of 1. We represent that using this arrow. Similarly, Q1 has a transition to Q1 on both symbols 0 and 1. We represent that using a single arrow. We know that Q1 is the final state. We have to mark that in the transition table as well. Let us see the mathematical definition of both the machines. Let's name the NFA with M2 and let's name the DFA with M2 cap. We know that M2 is given by Q, sigma, delta, Q0 and F. Similarly, M2 cap is given as Q cap, sigma, delta cap, Q0 and F cap. For M2, Q is Q0 and Q1. Sigma is the alphabet 0 and 1. Delta is the same as transition type table for NFA. Q0 is the initial state. Similarly, for M2 cap, Q cap is a set of states. In this case, it is Q0 and Q1. Sigma is the binary alphabet 0 and 1. Delta cap is a transition function for the DFA. Set containing Q0 is the initial state. Set containing final state Q1 is the final state. We have seen two examples of conversion of NFA to DFA, one with the strings starting with 0, one which containing 0. Let's see the last one, that is ending with 0. First, try to construct the given NFA. Starts with the initial state Q0. We will wait for the end 0 to arrive. Whenever we get the final 0, we will go to the final state Q1. Now we are done with the construction of NFA. Let's draw the transition table. As we can see from the diagram, Q0 has a transition on both Q0 and Q1 on the symbol 0, and it has a transition to Q1. As we can see from the diagram, Q0 has a transition to both Q0 and Q1 on symbol 0, and it has a transition to Q0 on symbol 1. Similarly, Q1 has no transition, and hence both symbols will have a dead state on encountering Q1. Now let us transform the NFA table to a DFA table. We have to start with the initial state. Here Q0 is the initial state and Q1 is the final state. As and when we will encounter new state, we will be entering that into the table. Q0 on 0 has a transition on both Q0 and 1. So we will form a new state Q0 and Q1. Q0 has a transition to itself on encountering 1. We have encountered a new state, combined state of Q0 and Q1. Let us see the transition of Q0 and Q1 on the symbols 0 and 1. Now we have to mark the final state. In the NFA, we know that Q1 is the final state and the only state which contains Q1 is the combined state Q0, Q1, which will be our final state in the given DFA. Let us try to draw the DFA for the given table. Now you can see the given DFA accepts the set of all strings which ends with 0, because whenever we have a transition on 1, we will come back to the state Q0, and whenever we have a transition on 0, we will go to the final state. And hence, whenever the string is in the final state, we will ensure that the final symbol that we have, whenever we reach at the final state, we will make sure that the final symbol that we have seen is 0. Let us see the mathematical terminologies of these automatas. Let us name this machine M3 and let us name this machine M3 cap. As we can see in the machine M3, Q0 and Q1 are the states, 0 and 1 is the alphabet sigma, delta, that is the transition function, is the transition state table for the NFA, initial state is Q0 and the final state is the state Q1. Similarly, for the machine M3 cap, here Q cap will contain the state Q0 and Q0 Q1. Sigma is again the alphabet, binary 0 and 1. Delta is the transition function for DFA. Set containing Q0 is the initial state and the set containing Q0 Q1 is the final state. With this problem, we have completed the construction of DFA from given NFA for easier problems. From next video, we will be doing more complicated problems of converting NFA to DFA. Thank you for watching this video. Stay tuned to Ekeeda and do subscribe to the channel.